Hi 30-2s, a nice short little lesson today. All we're going to be doing is a little more work on combining the laws of logarithms. So at the top of the lesson today, they do a nice job just showing you the three basic laws, okay? So product law, quotient law, and power law. Those three we're going to use over and over again to simplify log expressions, okay, work through some problems, and then next day we're going to use those to solve equations. But just a little more practice today on bringing them all together and how we use them simultaneously in some questions. So class example 1 reads like this. Students were asked to express 4 log base x2 minus log base x8 in terms of a single logarithm. Okay, so to bring them all together. The work of 3 students is shown below. So we have Shane's work, Emma's work, and Clayton's work. Only one of the students has determined the correct answer. Determine which student is correct and explain the errors made by the other 2 students. Okay, so when you take a look at the 3 students' work, okay, what I will tell you right now, okay, is that it is Shane, okay, who has the correct steps and ends up with the correct solution. Now, what I will do is instead of writing out what every student did wrong, is I'll just describe it to you and then circle their errors in their work, and then if you want to write in the open space below what I've kind of shown you, then that's great. If not, and you understand what I'm talking about, then obviously you can just move on in the section with me as we move forward. Okay, so Shane did everything correctly, okay, when you take a look at what he did. So first thing he did is he took the number 8, okay, rewrote it as 2 cubed, okay, because 2 cubed is 8, okay. Then he moved the 3 down in front. Now he just subtracted log x's. He had 4 log base x2s, and he subtracted 3 log base x2s. They're the same thing, so he ends up with 1 log base x2. So that is correct. Okay, that's not a problem. Everything he did was correct. Now, in Emma's work here, okay, the error she makes isn't really until the very end right here, okay? She does everything correctly. She takes the 4 that's in front of the first log and makes it an exponent. That's okay. She then evaluates 2 to the 4, which is 16. But it's at this point she makes an error. She is subtracting log expressions that have the same base. She should have divided the arguments. She subtracted them. So she should have had log base x of 16 divided by 8. Okay, that's what she should have had. Okay, and that would have taken her to log base x2, but she subtracted the arguments. She should have divided them. Okay, so that was her error. Now in Clayton's work, okay, let's take a look at what happens here. His error actually is right off the bat, okay? So the 4 that was in front of that first log expression should have gone up here as a 2 to the exponent of 4, and that number should have then been 16 and not 8, okay? His step here of dividing the arguments is okay, and the calculation he does is okay, but he used the wrong value, so it's right there, okay, that his error was made. So that is why Shane is the only one that has correct work. The other 2 tried, but made some silly errors along the way. Okay. Now, use laws of logarithms, which are the 3 at the top of the page, to write each of the following as a single logarithm. So again, what I want to take a look at first is the following. I am subtracting log expressions, and they do have the same base, okay? That's, obviously vital, okay? If they don't, then I can't use the laws of logarithms. First thing I'll do is in the first expression is I'll go log base a of 16, and I'll move the 1/2 up to be an exponent, and I'll do the same thing with the log expression. So this will be log base a of 8 to the exponent of 1/3. Okay. Now we know that when we raise something to the exponent of 1/2, that's like taking the square root. So this will be log base a of 4. And when I raise something to the exponent of 1/3, that's like taking the cube root. Okay. So the cube root of 8 is 2. Now I'm subtracting log expressions with the same base. I can divide the arguments. So it's log base a of 4/2. Okay, and 4 divided by 2 is 2. So this is log base a of 2. There's your final answer. Okay. The second one, okay, again, sometimes we forget here, but you notice it doesn't appear that there is a base there. That base is obviously the value of 10, okay? So I'm okay here to use my laws of logarithms because they all do have that same base, which is 10. So what I'll do is I'll just deal with these 2 first, the first 2, and I will go like this, log base a, and I'll actually just go minus log e to the exponent of 5, okay? So when I do that, okay, I am now subtracting log expressions with the same base. I divide the arguments. So this will be log base 10 of a all over e to the 5th. okay? So that's what happens when I bring those first two together. Now it's that, this is still coming down, so you still have to subtract the log of a squared. So we are subtracting log expressions with the same base, divide the arguments. So this will just end up being log base 10 of a all over now. You will have a squared and e to the fifth, okay? At this point, all I can do is I can simplify because this is like a to the exponent of 1. So I have a to the exponent of 1 and a squared. I can reduce this expression by canceling out 1a. So then I will basically have log base 10 of that a up there is gone, 1 over a e to the exponent of 5, okay? And there is your single logarithm, okay? So that is done. Next page, okay? Very similar type question, write the expression as a single logarithm and then evaluate the expression. So this time when they say evaluate at the end, that means they also obviously want a numerical value. So first thing I can do here is I can take the first expression and write it like this. So log base 6 of 4 squared. Okay, that 2 in front goes up to be an exponent. Plus, this is going to be a tough one. We're going to basically just, I'm going to leave it like this for right now. Log base 6 of 2.25. Okay. So from there, what I will do is turn this into log base 6 of 4 squared, which is 16, plus log base 6 of 2.25. Okay, and now I am adding log expressions with the same base, so I'm going to multiply the arguments. This is going to be log base 6 of, you're going to go 16 times 2.25. Okay, so this is going to be log base 6, and you're going to see that that actually gives you 36. Okay, so that works out pretty nice for us, and the value of that is going to be 2. And there you go, you're done. Okay, so it didn't look like it was going to work out that nice in kind of the middle of the question, but it did when I multiplied the 16 by the 2.25. Okay, all right, next question here. Now it says if log base 5p equals 12, okay, so that's kind of the key to our puzzle, to determine the exact value. Okay, so they don't want decimals, they want us to try and get values that are precise. Okay, so we should be able to do most of this without our calculator. So in the first question, we do have 5 times log base 5p. Now they told me in the write-up of the question that log base 5 of p, okay, is 12, right? That's right in the write-up of the question, so 12 times 5, that's just 60. Okay, we're done. Now in B and C, okay, you should put some stars beside these ones, okay? These are the types of questions that they ask quite often, and people forget, okay, that when I take a look at the argument here, these two things are being multiplied to each other, right? It's 5 times p. So I can actually separate that into log base 5 of 5 plus log base 5 of p. Okay, that's our product law, but I'm going the other way. It's like they gave me the simplified version and I broke it into 2 log expressions where I'm adding them using the same base. Because if I gave you log base 5 of 5 plus log base 5 of p, and told you to bring them together, you would get log base 5 of 5p. Now, the reason that's important is because I know log base 5 of 5 is 1, right? When the base and argument are the same value, the logarithm has a value of 1, and they told me in the write-up of the question that log base 5 of p is 12. So 1 plus 12 is simply just 13. Okay, same kind of idea in C. You notice that the argument here, okay, are two things being multiplied. So I can go log base 5 of 25 plus log base 5 of p to the exponent of 3. So log base 5 of 25 has a value of 2 plus the 3 that's the exponent. I'll bring it down in front using the power law. Log base 5 of p. And in the question, they told me, remember, that log base 5 of p has a value of 12. Okay, so this is 2 plus 3 times 12. 12 times 3 is 36, plus 2 more is 38. And there you go. Okay. All right, last question. And again, same kind of idea here. They give me a piece of information at the beginning of the question that's imperative to the rest. So if log base 2 of x equals a, use the laws of logarithms to show that log base 2 of 32x squared is equivalent to 5 plus 2a. So what that means is I'm going to start at this, and I should end up with that at the end of the question. Okay, so let's see what happens. So I'm just going to write out log base 2 of 32x squared. Okay, so again, I'm going to separate that into log base 2 of 32 plus log base 2 of x squared. Okay, same as I did in the last two questions in the previous section above. So now what I can do is log base 2 of 32 is a value of 5, right? Because 2 to the exponent of 5 is 32. Plus, I'll bring that exponent of 2 down in front, log base 2x. Okay, and there's that log base 2x that they told me in the question equals a. So this is 2, and I replace that with a. And there you go, 5 plus 2a, exactly what they wanted me to end up with at the end of the question. So that's it. You're just going to be using this stuff over and over and over again throughout the lesson. See how you do with it. Any questions, email me. I will get back to you. If not, I will post another lesson either tomorrow or Monday. So just keep checking the Google Classroom for those updates. And again, tests, quizzes, those types of things. I will let you know as soon as I know the dates and how we're going to roll those out to you guys.